Welcome to the final video on using superposition to solve indeterminate structures. In this, we simply, having finished our boundary conditions for our deformation of these individual portions, we're going to combine them, adding a final boundary condition that the deflection at point B must be 0. Once we've done that, we can then solve for our force at B, and then we can just solve for the reactions we have at A and C with our remaining equilibrium equations. We're finally ready to combine the loadings for this and this. When we do that, we're going to end up with, the effects of having both of the loadings present. So that'll give us our shear diagram if we just combine the two shear functions, our moment diagram if we just sum the two moments diagrams, the rotation, and the deflection. And that's the important one because at the very beginning we had a roller there, and our real problem was a distributed load over a continuous beam that had a roller at B. So the sum of the deflections at B has to equal 0 once we do all the superposition to it. And that is going to be, the deflection we have for that with 6B plugged in. Let's call them 1 and 2. Okay, and that is going to give us 1 over the second moment inertia, and the Young's modulus. You'll see those are going to wash out. As long as it's constant, it doesn't matter. I don't even think that I mentioned what they were in this problem. Times 1 kip times 6 feet cubed minus 1 kip over 24 feet times 6 feet to the fourth plus negative 72. Let's see, 2, I believe. Kip feet squared times 6 feet. And then let's start a new line because I'm not sure this will fit. It'll fit. It'll fit. We'll make it fit. Plus by over EI times negative 6 feet, let's put parentheses there, cubed over 12 plus 9 kip feet squared times 6 feet. Yeah, that's the right unit for deflection. Has to all sum to 0. Oh. So with all of that, that's going to give us, constants. All of these are real numbers up until, except for by. So by, this gives us 7.5 kips, which you may recall from Friday was what we got for that. That gives us AY equals CY equals 2.25 kips, and if we if we want to look at their shear functions, right, it's going to look a little something like this, right? We're going to pop up 2.25 dive down to negative, is that 3.75? Up to positive 3.75. Down to negative 2.25. And up to 0. And then our moment is similarly going to, this isn't quite as low as it should be. It's going to be positive, negative in here, and then positive out here. So we're going to have some regions of negative moment in here. Presumably, for most of you, you're wondering why on earth I told you how to do it the way that we did it on Friday, and that's just the way it is. You know, sometimes you gotta learn the hard way before you're learning the easier way. I think this is the easier way, at least, but your mileage may vary. So stay safe.